Okay, so in the last class, we were discussing about the fuel injection system in the SI engine, in which we have started our discussions with port fuel injection system, in which we have first of all discussed about the arrangement or the how the fuel injection systems are arranged in the engine, different parts, how we can measure the mass flow rate of the air. Either it can be measured directly with the help of sensor like hot film anemometry, or there's another way to measure the mass flow rate of air with the information of several other inputs like throttle position, manifold pressure, manifold temperature, throttle geometry, engine speed, and engine geometry. Then we discussed about how the PFI injector looks like. It is an electronic injector, and based on the duration of injector opening, the amount that will define the quantity of the fuel that has to be injected. So we need to do some sort of offline calibration between the duration of injector versus quantity of the fuel. So that calibration has to be done for a particular injector, and then that information has to be stored. So it means, okay, we'll come later on. So here up to here we have discussed. Now let us, okay, this part, what you can see here, this is your electronic throttle. Okay, some must, in other way you can find the name of that electronic throttle is like a drive-by-wire mechanism. So this is your throttle part. Okay, this is throttle plate that is going to be open and close depending upon the accelerator position. Then, in fact, it is driven by a motor. Here is there is a servo motor at this section, and then at these sections there is a this throttle shaft is connected through the series of through the gear mechanism. Here there is a gear mechanism and it is connected with that. Servo motor gets the feedback depending on how much you have pressed the accelerator. Accordingly, this throttle plate is going to be open and close. It has some feedback signal also. So suppose if it is supposed to be it is 20% open, whether it has 20% opened or not, that kind of the signals ECU will also get it. So that is called drive-by-wire mechanism. Now, if you look this schematic diagram, what we can see, this is your intake manifold. Here, there might be possible that if it is a high-end engine, then you have a hot film anemometry sensor. Okay, and then whatever the air is flowing through it, that signals will go to the ECU. Then we have a throttle. How much throttle has been opened, that much signals will also go to the ECU. And then depending upon the your logic and the way you have designed your engine control unit, based on that, it will ECU will send the signal to the injector. And that will ECU will send the signals to the injector, and it will define the pulse width of the signal also, because that will determine the quantity of the fuel, and that for that duration injector is going to be open, since injector is connected with the high pressure fuel rail. So as soon as this plunger moves up or it is in open condition, the fuel is going to be injected. Okay, and then during the suction stroke, it will go into the combustion chamber. In the exhaust manifold, we have a 1 and lambda sensor. So depending upon the mass flow rate of the air and some other inputs, the ECU is deciding that how much fuel we have to inject in order to get the optimum air fuel ratio inside this combustion chamber. But whether it is actually whatever it is desired, that we need to know. So for that kind of the purpose, we need some sort of the feedback, and that feedback will come from the lambda sensor, because this lambda sensor will give the value of air fuel ratio on which the engine is actually running, and that feedback will go to your ECU. Then ECU will compare the signals from the lambda sensor and based on the measurement of mass flow rate air and the how much fuel it has been injected. It is going to compare it, and it makes sure that both way of air fuel ratio calculated by both way, it has to be same. If it is not, then what ECU will do? ECU will try to tune the parameter. Tune the parameter here, it will going to tune the pulse width of the injector so that the air fuel ratio calculated from this side should be equal to the air fuel ratio whatever the lambda sensor will giving from the exhaust sides. So this is the way, in a very simple way, that the way I have explained to you. In general, this is the basic logic through which the ECU is going to control the injector. But obviously, when you are going to deal with actual condition, there are so many parameters are there, like fuel composition, and there are so many kind of the signal conditioning kind of the unit. So everything is going to be there, but the basic thing is the remains same. Last class we have discussed, there was a question that this whatever the accelerator pedal we are pressing, it is the signal directly going to your electronic throttle, or the electronic throttle is getting the signal via the ECU. So it in fact what happens whenever we press the accelerator. So the accelerator signals is going directly to the ECU, and then based on that demand from the user in terms of the accelerator signals, ECU will send the actuation signals to your throttle, and then throttle is going to be opened, and then whatever it has actually opened or not, that is the feedback signals, it is again going to the ECU, and then ECU is going to compare these feedback signals to the actuation signals and make sure that throttle has opened as it is. Why it happens? The question is why it happens. It happens because it is not only based on the acceleration's demand, the throttle is going to be opened. OK, that kind of this is also, we can say, one of the control system. But now the control system is based on torque demand based calibration. What is the torque demand? Torque based demand signals. It means, let us suppose when you are running the engine, or you are starting the engine, there might be possible that at that time itself your music system or even AC was on. OK, so when you are turning the key or when you're running the engine, at that time engine needs a lot of power, but at that time you are not pressing the accelerator. Then how the torque demand is more, because it is not only going to start, but it has other auxiliary systems is also required some power, and that power has to come from the engine. So for that kind of the signals situations, ECU, without getting the signals from the acceleration pedal, ECU will send the actuation signals to the throttle, that even though there is no demand from the user sides in terms of the acceleration signals, but engine needs some extra power to run the auxiliary systems, and therefore the throttle has to go to be in open condition. Similarly, either you are run the engine, sometimes you are switching on and off the other systems like AC or music systems or whatever, but you are not changing the acceleration position. But you want but then in that conditions also ECU auto twin the opening of the throttle. So that when we have a torque based demand or calibration map, then in that situations what happens that acceleration signals, first of all it will go to the ECU and then ECU decides the throttle opening based on the user requirement and the some power may required for other kind of the purpose. Accordingly, throttle is going to be opened. So that is the what it happens. I hope this is clear now. Now,
But,
yes,
yesterday you mentioned that accelerator and throttle are directly connected.
that I told you that is it also happens like that. But now it all depends upon what way you have. You are calibrating or you are designing your control system. Nowadays, the calibration system is based on the torque demand based. Initially, it was the based on the acceleration position. So it was like that. Now it is a torque based demand system where it throttle opening is not going to depend only on the throttle position, but ECU will also see that whether the whole vehicle required some extra power also to run some of the other parts. And then ECU will decide the throttle opening based on the acceleration signals and the requirements of the other power. That is called torque based demand. If the calibration is based on the torque based demand, then the acceleration signals will not go directly to your actuators to your this throttle opening. But in this calibration is going to be changed depending upon the how good we want to control the engine. Now, some of the people are talking about the calibration based on the development of based on the IMEP, that how much IMEP is required. OK, because if IMEP is what it is divided by the displacement volume. So if your calibration is going to be based on the IMEP based, okay, that how much IMEP will need accordingly, everything is going to be open and closed. Then what will happen? The calibration itself, it more or less, it is going to be independent of the engine size. So same calibration is very much is going to be applicable for the other engine applications also. So it depends upon the what kind of the calibration or control strategy you have developed in your ECU. Accordingly, the signals is going to be flow. Initially, it was based on the acceleration positions. Now it is based on the torque based demand. Further people are thinking about the IMEP based the calibrations also. That was the story. That is the story. It all depends that what kind of the control systems you are developing. Accordingly, signals are going to flow here and there. Any question? Any questions regarding the how ECU will get the signals as far as the in a very basic ways? The ECU will get the signals from the sensor, mass flow sensors. It'll get the M.A. Then ECU will try to see that if I have to make the air fuel ratio 14.7, then corresponding to this mass flow rate, how much I have to inject the fuel. That is very easy to calculate it. Once this much amount of the fuel I have to inject, then ECU again look the calibration map of the fuel injector, that if I have to inject 2 milligram of the fuel, then for injecting the 2 milligram, how much how long the injector has to be open. That information you will get from the injector calibration map, and then accordingly it will produce a signals that will have a same pulse width, and that signals will come to the injector. Okay. Now let us see this fuel supply systems only. As we have already discussed part of it, that we have one is the fuel tank, second is the fuel pump. Yes, the last time in the last class, one of your friend asked that what kind of the fuel pump it is. So it is a positive displacement kind of the pump. The fuel pump that is situated in the fuel tank. From here, as soon as you going to turn the key, the pump is going to be on, and then it will pressurize the fuel, and then it will pass through the fuel filter and it will go to the fuel rail. This is your fuel rail. In the fuel rail, all the injectors are connected, and the rail, it is nothing but it is a accumulator and reservoir in which the fuel is going to be maintained at the pressure of around 3 to 5 bar. Okay, but for a given engine, the fuel in this rail is going to be constant. So once the fuel is going to be constant, then the how much fuel is going to be injected, it depends upon the how long the injector is going to be in open condition. And there might be some excess fuel or coming from the injector or from the rail, then some part of the fuel is also going to be in the return line. So that is the what we have the fuel line system in the port fuel injection system, that you have to always remember, or you have to know at least, that the PFI system, the fuel injection pressure is a constant parameter for a given engine. However, engine to engine there might be a slight changes, but if the two engine or even more engines have a MPFI kind of the fuel technology system, their fuel injection pressure is roughly it is going to be vary from 3 to 5 bar. That is what it is, the pressure range, fuel injection range. Now, so that is what as far as the control and the logic is concerned for the port fuel injection system. So now you see that we have a direct control over the how much mass of the fuel we have to inject, because we can change the pulse width of the signal, and accordingly mass of the fuel is going to be changed. So user or the developer has a direct control over the mass of the fuel injections. When it has to be injected, that can be also have a direct control. How much fuel has to be injected, there is also direct control. So we can say that in the port fuel injection system, there is a much better way to we can control the mass of the fuel, and overall we can control the air fuel ratio. Now there is another things comes into the mind. Now we know that the injector in the PFI system is installed in the intake manifold. And this is the what you can see, this is your intake manifold. 6 is the intake manifold, and 5th is the injector. And that part you can what you can see here, it is a rail. This one 4, and this part is our intake valve. This is our exhaust valve, a spark plug, and here we have a piston. This is the cut section. Now, question comes into the mind that where we have to inject this or install this injector. Can be installed anywhere in the intake manifold, or we can install the intake manifold at this point, even at this point, where we can install it. That's a very important part of this things. If you remove this injector, okay, you just take it out, this injector in the engine, and slightly somehow put the light because inside it is dark. and you put the light and then try to see it from here, you will see the back side of the intake valve. This part you can see it. So what I'm trying to say that in MPFI system, the injector location and its orientation is such that the jet, whatever it is coming out from the injector, it will hit on the back side of the intake valve. Okay, the injector location is such that, or its orientation is such that the jet directly hits at the back side of the intake valve. Why it is like that? We know that the fuel injection pressure here is very low in terms of what I'm saying in terms of the gas, diesel engine kind of the engine, where the fuel injection pressure is 1000 or 1500 or 1800 RPM. Compared to that, here the fuel injection pressure is just 3 to 5 bar. Okay, so the whatever jets are coming out from here, the fuel droplet size. Okay, the fuel droplet size in MPFI, it varies around 100 to 120 nanometer. Am I right? No, it's nanometer, micrometer. 100 to 120 micrometer. So because fuel droplet size is anyway, it's going to depend on the fuel injection pressure. Now, when the jet is situated in such a way, or injector is situated in such a way that jet will hit at the backside of the intake valve. Since the intake valve is a heated position, is a heated part, then as soon as the jet is going to hit it, the fuel is going to be evaporate. Because if it is if the fuel is a liquid, then our aim in the engine, either in the gasoline engine or in the diesel engine, to make it evaporate as fast as possible. So since the intake valve is a heated part in this zone, so when the jet will hit at the backside of the intake valve, the fuel is going to be evaporate very fast. It will mix with the air, and then the mixture of fuel and air, it will go into the combustion chamber during the intake stroke. So we put the orientation in such a way. If you put somewhere else, then what will happen? The jet, instead of the heating on this heated part, it is going to the heat on the internal part of the intake manifold, and that is at the not as heated as possible. Then what will happen? How much the fuel, the sum of the fuel, it may stick, okay, on the on the inner surface of the intake manifold, and it will not go to the into the combustion chamber. So you are sending, or you are injecting the fuel correctly as per your calculation, but not all the fuel is going into the combustion chamber, and that will create the mismatch. That it means that your air fuel ratio is going to be high. Now you can ask the question that, okay, that is really very good when engine is in the running condition and the intake valve is in heated conditions and fuel is going to be almost all are going to be evaporate. But what will be happen during the engine starting time? Because when engine is in, we have to start, okay, then at that time all the parts of the engine is going to be almost like atmospheric temperature. At that time, how it is going to be happen? Yes, that is one of the demerit of the MPFI system. That during the start of the engine, okay, since everything is at the normal temperature, when the fuel is going to be injected, okay, then not all the fuel that whatever it is injected is going to into the combustion chamber. Some of the fuel is going to stick on this surface, and the inside the air fuel mixture will be the linear. And right now even the combustion chamber is in the cold position, so the combustion, there might be possibility that there will be misfire, and misfire is going to be takes place. If it is a misfire, then what will happen? Whatever the hydrocarbons into the combustion chamber, without burning, it is going to the atmosphere. So it means you are going to have a larger SC emissions, hydrocarbon emission. Then what happens? So during the starting time, you have to control, you have your system in such a way that the combustion must be start with within the very minimal rotation of the crankshaft. When we are turning the key, the engine will take at least one rotation before a start to the engine. It needs to take one rotation so that the engine will know that where is the piston position. So one rotation is required to get the synchronization of all the signals. Once and then after that, there is a possibility that the engine can be start in the second rotation of the crankshaft, if that is the best conditions. So sometimes you may find out during the cool time, then you are cranking the key and engine is running 2, 4, 5 rotation, and then after that it is going to be a start. Sometimes it's a bit difficult, even too much. Particularly you may have some practical experience of such kind of the things also. But in the summer, hardly 2, 3 revolutions and your engine is going to be a start. So that starting time or a startup procedure, that is one of the demerit of MPFI engine, where the fuel is going to stick on the backside of the valve and not all the fuel is going injected is going into the combustion chamber, making it a linear mixture, and your engine is not, there might be possibility that it will be misfire and combustion will not initiate. This phenomena is called valve wetting. Okay, where the fuel is going to stick on the valve. That phenomena is called valve wetting, W-E-T-T-I-N-G, wetting. So that is one of the demerit of MPFI engine of the cold start. To avoid this situation, okay, that engines can start as soon as possible, we need to the sum of the, it depends upon how kind of the logic you are using it, but sometimes what people do, they inject much more amount of the fuel than what it is required, even 3 to 4 times fuel you have to inject it, so that in the engine can start as soon as possible. Once it is a start, obviously everything is going to be hot, and then after that it is going to be fine. So that is one of the demerit that of the MPFI engine, is that the valve wetting or during the startup process at startup time. So now obviously each system has an advantage and disadvantage. So when we are comparing with respect to the carburetor, where we don't have a direct control over the fuel injection because it is based on the pressure difference that is created inside the carburetor. But when we shift from the carburetor to the MPFI, then here we have some control. We can control it when and how much we have to inject. So we have a direct control over the air fuel ratio. But it has a certain limitations also, as one of the things is valve wetting kind of the things. Now, how we can even avoid this valve wetting phenomena, and we have even much more control over the engine. If we are going to inject the fuel directly into the combustion chamber, okay, just like in the diesel engine, then what will happen? This valve, at least the valve wetting phenomena, is going to be completely removed. And then we don't need to inject too much of the fuel. And always during the whole operating condition of the engine, it is true that whatever the fuel it is going to be injected, it is always going into the combustion chamber. So once we replace this location of the injector from the manifold to the cylinder head, and the opening of the injector is going to be into the combustion chamber. So it means we are injecting the fuel directly into the combustion chamber. Obviously, it is not so simple that take it out the injector from here and install it into the combustion chamber, because now we are injecting the fuel into the combustion chamber. The situation or the environment in the combustion chamber is completely different what you have if you have in the manifold. The injection pressure and everything is going to be slightly tuned. So obviously we need to have some even more with the fuel injection has to be more. So we need to inject the or we need to pressurize the fuel even at much higher pressure. So when we are okay, before that, this is one of the fuel line in the vehicle. Just I have taken the picture from the internet that you can see it here. How in the real engine we have. See, this is the fuel tank. So once in the beginning of the class, when I was asking that where is the fuel tank, mostly the fuel tank in the engine is at the bottom side, at the back side. Here we have a opening through which the fuel is going to be filled to the tank. So this is your tank. Inside that we have a fuel pump. Okay. And then it will come to the, from here. It's pressurize the fuel. It is coming to the fuel filter, and this is your rail, in which the fuel is going to be stored. And here we have an air filter that is coming the intake manifold sides filter, and the air is coming at this point. Here we can see this is up to the here, and then injector is installed at this point. So overall, this is the structure of the fuel line and the systems in the vehicle. Okay, now do you have any questions up to here? What we have discussed?
Sir, even if we supply the fuel directly to the combustion chamber, we are not evaporating it firstly.
Yes, so that's the reason I told that there is some we have to change the some of the other things is also, as I told you that what I am going to discuss it, because now we are injecting the fuel directly into the combustion chamber. There we are not going to get the uh, one of the beauty that MPFI had, that evaporation. Then what we need to do, as I told, that we need to evaporate the fuel as fast as possible so that the fuel and air can mix with each other. So the evaporation, to increase the evaporation process, we need to do something else. We have to rely on some process else, for which we need to inject the pressure at much higher than what the injection pressure has in the manifold pressure. So once if you increase the manifold pressure, injection pressure, then what will happen? The fuel droplet is going to be reduced, and then what will happen? The surface to volume ratio is going to be increased, and then the water it will be easy or it will be faster is going to be evaporate even when you are going to inject directly into the combustion chamber. So that we are going to discuss in the gasoline direct injection system. Anything else? While waiting demerit, I hope everything is clear to all of you. See, the thing is, one thing I would also like to inform at this point to all of you, that in the MPFI system, okay, port fuel injection system, I was saying that when we have to inject, also we have a direct control over it. So when we have to inject, that is also is a really very good parameter. That is also ultimately going to determine the homogeneity level of air fuel homogeneity level inside the combustion chamber. And that is going to be much more important, or we can say in other words, that in MPFI, the when we have to inject is very much critical if you are using the gaseous fuel. Gaseous fuel in terms of saying CNG, because nowadays in India CNG is widely used everywhere. So when we have to inject the CNG, it's a very critical parameter compared to the gasoline engine, because it is a liquid fuel. So that's really very important. However, I'm not going into too much details in it, but just one thing you can explore later on, that the fuel injection timing in the MPFI engine is very important and critical parameter if you are using the gaseous fuel compared to the liquid fuel. In the short, we can say that when you are injecting the gaseous fuel like CNG, in the intake manifold, it is a gaseous fuel. When the injection takes place, what happens? It expands in the intake manifold itself. And then what will happen? It will occupy some of the space of the air, and ultimately the volumetric efficiency of that engine is going to be lower down. Then the overall power is going to be reduced. So right now, when we have if you are going to introduce the CNG in the gasoline engine, the maximum power of the CNG fueled engine is going to be reduced compared to your gasoline fueled engine. It is approximately 10 to 12%. The maximum power is going to be reduced because of having lower volumetric efficiency. If you are using the same engine for gasoline and the CNG. So there we have to do something else so that we can recover our lost power. Okay, so but in gaseous fuel, in the liquid fuel, the fuel injection timing is not going to be too much affect the power output. Yes, it has a very minimal, but it's not up to the way it affects the gaseous fuel. Okay, so now if we want to inject the fuel directly inside the combustion chamber, then such kind of the technology is called gasoline direct injection, GDI. Anyone can give me example of Indian car or model which has the GDI technology? Any car model which have a GDI?
Maruti 800.
Come on. Have you seen the Maruti? Maruti 800 right now anyway is not under the manufacturing unit. Maruti has discarded. Instead of that, it has some else model or Maruti Alto 800, something like that. It has come out. Maruti Alto or Maruti 800 is the very basic engine. It's a very basic engine. They have GDI is the advanced technology there. And most of the engine has a PFI engine. GDI is advanced technology system. It requires extra hardware and extra control systems. Obviously, the cost of such kind of the engine or technology is high. It's not the Maruti is a high-end car. We have the GDI system. Like, have you seen one of the very first engine? Probably it comes with the GDI technology is the Ford Eco Sports. Okay, some of the engine of so many engines at the higher end also we have GDI, like BMW and so many others engine also. But in general, what we can see in general in anywhere, I hope Ford EcoSports is a very common car, and because of its look and very powerful engine, that car or SUV has a GDI, gasoline direct injection technology. You may explore some of the car or company also that has equipped with gasoline direct injection system. So what have gasoline direct injection system? Nowadays, gasoline direct injection system is very popular technology. Particularly, it is very much popular in the Europe because they have even slightly tougher emission regulations than us, slightly. But we are reaching very fast with the, we will discuss later on the emissions part. So but in India is still the PF5 injection technology is dominating technology as far as the gasoline engine is concerned. GDI is still evolving. That it's not evolving, it's in the used part. It has been already evolved technology, but it is not any used. But yes, it is going to come at a very fast because of the emission norms. So if it is your engine is equipped with gasoline direct injection system, then our traditional statement is going to be no longer valid, where we say or we read that in auto engine or in gasoline engine, it is a mixture of fuel and air comes into the combustion chamber during the intake stroke. That statement is no longer going to be valid now. And this is the reason, okay, that when I was making such a comment on like that one, previously I always use the terms that in general, in gasoline engine, it is a mixture of fuel and air comes into the combustion chamber, because that statement is not going to be valid if the engine is equipped with gasoline direct injection technology. Okay, so if it is a GDI, then even if in the spark ignition engine, it is only air will come into the combustion chamber during the intake stroke through the manifold. So what happens? Just look at this drawing. Here we have a fifth is the injector. Okay, sixth is the rail. Again rail, but that rail is slightly is it completely different that we will discuss later on. Here we have an injector, and the injector is installed in the intake sorry, what I'm saying, in the cylinder head, and the opening of the injector is directly comes into the combustion chamber. And these are the valves. Third is the spark plug. The second thing what and the first is your piston. Now see the shape of the piston. It is a completely different. What we have discussed in the beginning of the class, that if we have a two piston, then in general, at that time we are discussing like that. In general, we can distinguish that the which piston belongs to which kind of the engine. It is a belongs to gasoline engine or it belongs to the diesel engine. And then at that time we discussed that if the on the top of the piston, okay, it is almost flat, then it belongs to the gasoline engine. If it has some groove or very complicated kind of the shape, then it belongs to the diesel engine. But now you see we are discussing right now the gasoline engine, but see the shape of the piston. It is no longer it is a flat. It is also have a very different kind of the design. But what we can say that when if you go to the in details of the gasoline direct injection system, okay, then you might find also that the gasoline engine also has a very much flat top of the piston. That why I'm saying like that we'll discuss in very short. Right now, what my intention is here to introduce the gasoline direct injection system is to just give you the overview and not go into much details. But what I can recommend to all of you that in gasoline direct injection system, gasoline management system, that book written by the Robert Bosch is very good book. It's just 10-15 pages are there for the GDI system, and without any just the technology involvement and how it works. It's very good things. I would request all of you that just read it. It is a kind of the novel. So what I'm going to discuss it here, that in gasoline direct injection system, the injector is located in the cylinder head and the fuel is going to directly injected inside the combustion chamber. That is what it is making a completely changes from what we have learned till now in the MPFI system. Now, when it has to be injected, it is another a very important parameter in the GDI system. In gasoline engine, liquid fuel itself, when you have to inject, you have a wide flexibility. You can change it as soon as the intake stroke is going to be initiate, and then you may end off the injection before the a spark is going to be created. So you have almost all intake stroke, and also you can say most of the part of the compression stroke. When you have to inject, you have such a wide flexibility, and then you are going to optimize the engine. But you need to also know that when you are injecting the fuel during the compression stroke, then what will happen? Then the environment in which the fuel injection will take place is completely different. The fuel, the pressure and the temperature inside the combustion chamber will be very high. So the fuel injection pressure has to be much more than what when you are injecting in the intake manifold during the intake stroke, because at that time the pressure is inside the combustion chamber is very less. So in gasoline direct injection itself, okay, we can divide the two kind of the combustion mode, that is called combustion mode, or we can right now we can say is it two kind of the GDI, we can say, based on the combustion. When you are injecting the fuel in the intake during the beginning of the compression stroke, during the beginning, or let me another way to say, when you are injecting the fuel, okay, during the intake stroke, or when you are injecting the fuel towards the end of compression stroke. One in which you are injecting the fuel in the intake during the intake stroke itself, then such kind of the GDI combustion is called homogeneous combustion. And when we are injecting the fuel towards the end of the injector, end of the compression stroke, then that is called stratified combustion. These are the two different kind of the mode of gasoline direct injection system based on when you are injecting the fuel. One thing we have slightly discussed this part during our discussion of gasoline and diesel engine, 4-stroke gasoline and 4-stroke diesel engine, that since we inject the fuel in the intake manifold in the gasoline engine, then the fuel and air has a lot of time to mix with each other and form a homogeneous mixture. Whereas in the diesel engine, we inject the fuel, okay, about to end of the compression stroke, or even after that also sometimes. So the fuel air mixture is not homogeneous in the diesel engine, and we call it heterogeneous combustion. In GDI, when you are injecting the fuel into the combustion chamber, either you may injecting at the in the middle of the intake stroke or in the late part of the intake stroke. One thing is very clear, that you are going to little bit, or it depends upon the other parameters, compromise with the homogeneity of air fuel mixture. Okay, and that was the beauty of the gasoline engine. When you're injecting the fuel into the intake manifold, that it is a homogeneous combustion. But here you are compromising little bit with compared to the your PFI system in terms of the homogeneity. So each mode of the combustion has an advantage and disadvantage. Right now, okay, that a little bit details I will discuss in the next class. But right now, whatever we have a GDI technology, particularly in India, all of them are working in the homogeneous combustion mode, in which you are injecting the fuel in the intake stroke or in late intake stroke, and that is called homogeneous combustion. Controlling the stratified combustion, this is very efficient combustion mode, okay, where we can save a lot of the fuel. So but right now the controlling of the stratified mode, achieving the stratifications in the air fuel mixtures, and it's controlled over the wide range of the operating conditions itself a challenging part. When you are going to combine the homogeneous and stratified combustions in the gasoline engine, okay, it is going to be really very efficient and less emissions for a pollutant engine. But still, right now, this stratified combustion of GDI is still limited and not it at least production engine, it is still very limited, but whatever the GDI we have right now, all of them are homogeneous combustions. I will little bit discuss even more about that in the next class about that. Okay, without introducing anything else, you may ask some questions. We have some time. Any question?